Hello and welcome, I'm your Code Monkey. Unity's 2D tools have massively improved over the past few years. They've already been used to make several gorgeous, awesome games. Notable examples include games like Cuphead, Hollow Knight, Among Us, or even games that mix 2D and 3D like Dave the Diver or Cult of the Lamb. To help you make games like that, Unity has just released an excellent brand new sample with all of their 2D tools. You can get it for free from the asset store, so check the link in the description. Alongside the sample, there are also various blog posts to help you learn and use all of these awesome 2D tools that Unity has. You can use 2D lights and normal maps to make your game look really excellent. You can add shadows and day-night cycles. Then you can build worlds and lots of logic using these 2D tilemaps. Next, you can use 2D rigging and AK to set up your character with bones. You can use the PSD importer to easily import your characters and animate them inside Unity. And finally, you can learn all about how to use the VFX graph to make awesome 2D particle effects. So let's inspect this sample and read all these articles to learn about all of these awesome 2D tools that exist nowadays. There are many of these that you might not be familiar with, and might be incredibly useful to you if you're working on 2D games. For me, lately I've been working mostly on 3D, so a lot of this has been new to me, and I've already learned quite a lot from this sample. Also, this video is sponsored by Unity. Check the links in the description to download the free sample and read all the articles. There's a ton of info on all those articles, so here I'm just going to cover a quick high-level overview of all of this. So do make sure that afterwards you check all these articles and you read through them yourself. There's timestamps in the video if you want to jump ahead. Okay, so here I've got the project loaded into Unity. There's a nice main menu, and then it jumps right into gameplay. So it starts off on this really nice inside scene. Right away, you can see a bunch of really interesting dynamic lights. You can see the light effects on the character. You can see the character rotates as I move the mouse. You can see the timer, the coins, menu, and so on. And of course, if we go down here, we can go into the exterior. And if there you go, there's a really nice exterior. So we got a house, a real nice pig. Again, the time keeps going. And down here, we have a really nice farm. The game is basically a mini farming minigame. So I've got a bunch of tools down here. For example, I've got this hoe, I think. So I can go down, I can, prepare the land, whatever this means. I can water some plants. And I can take one of these seeds and just plant a bunch of stuff. So let's plant, what is this? This is wheat. Yep, let's plant it. Then using this little basket, I can start harvesting some things. And yep, I'm picking up a bunch of things. And that one is already starting to grow, and some carrots over here. And also note how the lighting is changing. So this has a really nice day-night cycle. And again, note all the rim light effects. All of the effects make it look really nice. And then at night, there's also a bunch more dynamic lights. So you can see over here, this dynamic light moving and moves around, so it looks really good. Then up here, there are also some buttons to control the weather. So this can be nice clear skies, or we can enable some rain, or even some really intense rain and lighting effects. So there you go, look at that, it looks really gorgeous. So some really nice particle effects on the background. There's the rain falling down. Of course, it's all being affected by light, so everything looks really gorgeous, really nice. All of it nicely animated. And I can walk around, I can explore this. I can see a bunch more effects. There's a bunch of water. There's also collisions and so on. And over here on the market, then I can sell a bunch of things. So let's sell a bunch of wheat, a bunch of carrots, and let's buy a bunch more seeds and so on. So I can do this, and then I can continue. So let's pick up some more wheat and so on, and as you can see, it's a really nice, really complete minigame. So right away, you can already see quite a lot of stuff. You can see how it's got a tile map in the background. You've seen all of the lighting effects. You've seen how they interact. The lighting interacts with the character in different ways. All the animations, all the interactions, the particle effects, and so on. So yep, that's pretty much how this is. A really nice, really cool sample showcasing all of the Unity 2D tools. Honestly, playing through this one really makes me want to make a step-by-step course on making a farming minigame kind of like this, something like Stardew Valley. I'm currently busy working on my upcoming Steam game, The Gardens. By the way, go ahead and add it to your wishlist. But after I finish this game, I do want to get back to making complete courses, so do let me know if a course like this on making something like Stardew Valley, something like a farming minigame, if you'd be interested in that. So anyways, yep, like I said, this is a great sample, a great, very functional minigame. As you can see, all of the great 2D tools being used, and the main one really is lighting, so let's begin with that one. There's a really article/tutorial that goes into a lot of detail over how all of this works. As you can see, this is insanely detailed, so like I said in this video, I'm pretty much just going to cover an overview, but definitely do make sure that you check the links and you go through them in detail one by one. There's a ton of info here, so if you want to make 2D games, definitely spend some time learning all about this. Starting off with dynamic lighting. Now, some of you might not be familiar with the fact that Unity actually has 2D specific lights. If you're making a 2D game, you should definitely use these and not the 3D lights. Over here in the inspector, when you go into add some object, you can go into light, and over here you've got these up top, these are 3D lights, and then down here these are the 2D specific lights. If you don't see these, that means you probably don't have the 2D packages installed. So over here, make sure you have these 2D packages. And then of course, make sure you are using URP, and make sure you are using a 2D renderer. With that, you should be able to see the 2D lights of all these types. For these ones, freeform is basically a 2D light that can have any shape you want. By the way, another quick tip over here on the search, you can press T, then colon, and then you can write some kind of type. So for example, over here, I want to see all the lights. So I'm going to type light 2D. And if there you go, I can see all of the lights that exist in this nice demo scene. So for example, here is a freeform light, and this one freeform has a certain shape, and you can create this shape on all kinds of vertices. This is freeform. Then you have sprite lights. These can use any sprite you want. For example, over here, the street lamp, this one has a sprite light, and you can see over there exactly what the shape of the light is. So it basically takes a sprite and uses that as the light shape. Then you have spotlights. These are super basic. So these are your standard lights that hit a certain area. So as you can see, that is a basic spotlight. And then you have global lights. This one does not have any shape. This one simply affects every single object on the world. Also, when using 2D lights, it is important over here to look at the target sorting layers. This is which layers will actually be affected by this light. For example, over here, if I move this light, you can see that it does affect the background, but if I put it over there near the character, you can see it does not light the character. Whereas if I modify this one to include another layer, let's say the objects, and I move it over there, and yep, now it does indeed light up the character. Also, another very important part about lights is make sure that your material is using a sprite shader. So go into any sprite render you have and make sure that on the material, you're using a sprite lit material. You can check out the shader and make sure that you are using a sprite lit shader. If you're not using this 2D shader, if you're using the regular one just by URP, that will not be affected by 2D lights. Then to take your 2D lights even further, one thing you can add are secondary textures. This is how you can add this nice little rim lighting. By default, the entire sprite won't be lit, but by using secondary textures, you can make sure the light only affects a certain part of it. To use 2D textures, you basically just go into your texture map. So over here, this is the texture map for the entire character. And over there on the sprite import settings, we can see that this one is being imported as a 2D sprite, and we can open up the sprite editor. And over here, we see all the body parts, so how that is set up. And if we go on the top left corner, over here, we can go down into secondary textures. And you can see that this texture does have two secondary textures. It has a normal map and a mask map. Then if we click on these, we can see how these are set up. You can see the normal map here with these gradients. This normal map, this is how you get that almost 3D effect, where the light hits different parts of the sprite differently. If I grab this light and I move it around, you can see a pretty big difference. Look at how the sprite is lit depending on where exactly the light is. The other map you can apply is a mask map. So masks are how you control where the lights affect the sprite. And specifically over here on this game, the mask map is used as a rim light. You can see that little rim lighting over there on the top of the hair. You can see how that one is different from the rest of the sprites. That really helps the readability in the game itself. As to how you make those normal maps, in the article over here they mentioned several options. If your workflow involves 3D modeling something before creating the sprite, then doing those should be pretty easy to generate. If not, then apparently there are some tools that can help you build them. Now, I'm not familiar with any of these, so I can't speak to the specific process. But regardless of which of these tools you use, in the end, you probably want to have an artist manually paint the lights and shadows. For the really important sprites like the main character, you probably want an artist to manually go ahead and modify each generated sprite to make it look exactly as you want it. Now, something really important in this sample is the day-night cycle. This sample contains a really awesome script that also contains a really nice custom editor where you can easily modify everything to see the change. You can see all the various lights that they use, as well as all the gradients. Basically, the way they make it work is with a global light and a directional light. Now, technically in 2D, you don't have a directional light, so the way they actually fake a directional light is simply by using a regular spotlight with an angle of 360, and then they simply rotate where exactly that light comes from. So over here, you can see that inside the main camera, there's a lights rotator. This is an empty game object where inside of it, they've got all kinds of day and night lights. And then the day-night cycle script, that one basically just rotates this game object. You can see over there the Z rotation, you can see it rotates. And if we select both of these, we can see daylight. And yep, you can see that it rotates up and down, and the night light pretty much does the opposite. So this is a really clever way of how to handle directional lights, even though the 2D system doesn't technically have directional lights. This is definitely a really clever approach. Personally, I had never thought of it, but obviously it makes a lot of sense. A spotlight that you move around pretty much acts like a directional light. So if you'd like to implement a day-night cycle into your own 2D games, I highly recommend you download this sample and look at this script and look at how all of this is set up. I think this looks really nice. The way they have multiple lights with multiple masks and over here using the gradients, I think this looks really good. And the other important thing related to lighting is obviously shadows. Now, there are multiple ways to add shadows. One way, which is somewhat counterintuitive, is to actually use a light. That is how they handle the shadows for this little building. Again, in 2D, this building doesn't actually have a shape, so in order to create this shape, they made a freeform light, and then they simply tinted that light in black. Another technique you can use are 2D real-time shadows. So like there, over there, the shadow on this little barrel, as I move it around, yep, it has a perfect real-time shadow. Adding this is super simple. You just go into any sprite and you add the shadow caster component. Then you can edit the shape in order to modify the shape that generates the shadow. And they also have a really excellent tip for how to apply shadows to your character. How you probably do not want to add shadows to the entire character itself. Doing that would make it look quite weird, so instead just add it to the feet, and like this it looks really nice. You basically just go inside the field bones and you add the same shadow caster component. Although these shadows, these are actually pretty harsh and infinite. As you can see in the article, they essentially are better suited for night scenes and not really for daytime scenes. However, during daytime, you still want some shadows in order to make your game look good, so for that you can essentially use fake shadows. Here in the daytime we can see how they made those fake shadows. So you can see over here this shadow for this tree, you can see how it rotates around. And this shadow is actually technically just a light. It is a light and then black. This one is a sprite light, so it has this little shadow sprite. And then the day-night cycle script, that one simply rotates this parent game object. Again, these are not perfect 2D lights, but this method looks much better during the daytime. And coming back to the shadow for the house over here, as we saw in the article, they basically use a freeform light. But if I modify the time, you can see how the shape actually changes in a really nice, really smooth way. This is yet another thing that you can take directly from this really nice sample. Basically, they have a really great script here inside the Light 2D warehouse. And it's a script that they call Light Interpolator. So basically inside they've got all kinds of freeform lights. These have all kinds of points. And then they basically use the script in order to generate a light shadow, a freeform light shadow, that basically interpolates between all these various frame points. And that is how you get this really nice interpolated freeform shadow. And one more nice tip is using blob shadows. So for things like the character, for that one during the daytime you probably don't want a harsh shadow, so you really just want a simple sprite right at the feet of the character. It's a simple thing, but it looks really great, and that's pretty much what all 2D games use. Now, when it comes to lighting, one big concern is always with regards to performance, especially if you're making mobile games. So this article has a bunch of tips to help you in that regard. The main one that you can use is really just use the frame debugger. This lets you basically see how each frame is being rendered. That can really help you figure out bottlenecks in your GPU rendering. Down here you can see all the various tips. Make sure your lights are batchable. Try to keep the render scale as low as possible. Minimize the number of shadow casting lights on screen. This is probably the best one that you can easily modify. Also minimize the number of blend styles. Again, there is a significant cost in all the algorithms that make up the blend styles. Or simply adjust the max number of lights. Okay, so all of this is a ton of info on the 2D lighting system. Then another tool that is used heavily in this sample is the 2D Tilemap. Again, there's another really detailed article with tons of info on making art and gameplay using 2D tilemaps. I covered a simple tutorial on how to use the tilemap some time ago. Basically, you can create a sprite asset, you can create tiles by slicing some sprites, then you can easily place them in a Unity grid using a simple brush. Then on top of that, you can add collisions, you can make more tilemaps, and build more complex things, which this article covers. So here in the sample, we can see all of the tilemaps, they're all in here under this grid game object. So we've got underwater tiles, water, ground base, and so on. So tons of tiles for all kinds of different types. Each one of these uses a different tile map. If we select one of the tile maps and over here we click on Open Tile Palette, over here we can see all the various tiles that make up this tile map. So as you can see, we've got a water tile, a bunch of grass, we've got all kinds of walls, ceilings, floors, and so on. This is all nicely separated into various layers, and the way you paint is you simply select the tile and then you simply draw on top of it. So if you're making 2D games, the tile map is really one of the most useful things you can use. And just like with lighting, you can also use secondary textures, so you can use normal maps in order to modify how the light impacts the various tiles. One of the most useful things is the rule tile. So this is how you can basically define some rules and then easily paint, and every time you paint, it follows along with these rules in order to figure out which sprite to select. In this sample, you can find all of the various rule tiles over here, so inside Happy Harvest, inside Art, Tiles, and then you've got the various ones, and most of these got a kind of rule tile. And over here, yep, we can see all the rules. So for example, the first rule, if you place a tile and there is no tile above it, no tile to the left, but there is a dirt tile to the right, under to the right, and under, if so, then it's going to select this corner tile. Then if it follows this rule, it selects this one, and so on. So yep, rule tiles are super important, super useful. If you're using the 2D tile map, definitely make sure you learn how this tool works. It's actually pretty simple and super useful. Definitely makes selecting all of these round tiles much, much easier. You just define the rules and then easily paint and everything looks correct. Here in the article, there's a really nice explainer on how all of the various tile maps are structured, how they separated them and why they did it, so why did they make an underwater tiles, water, and so on. And actually, in here, in this article, I learned about one thing that I did not know, which is the game object brush. I did not know that this existed. This one apparently lets you use a brush, like you use with any of the tile maps, but instead of painting tiles, you can actually paint regular game objects. This is something that I've seen being done by a bunch of tools on the Assessor, but I didn't know that Unity itself could do it, so I just learned something new, that's great. One area where it's really useful to spawn separate objects instead of just one tile is, for example, for dealing with sorting orders. If you put one tile map, then the entire tile map will have the same sorting order. But of course, if you have a tree over here and you've got another one down here, you want those to be on different sorting orders in order to show up one above the other one. So for objects that are not directly painted on the floor, for those you probably want to use a separate object, and using that game object brush is super useful to place them easily. However, tile maps are not just for visuals, that's the main thing, but it can be used for more than that. Like it says here in this article, you can use the Tilemap API in order to handle all kinds of gameplay. In this game, which is a farming game, for example the ground tile map, this one contains some logic based on the soil tiles to indicate where the player can dig and plant seeds. You can inspect the terrain manager in order to see all the functions that it uses to interact with the Tilemap API in order to read the various things and update the tiles. That one is placed over here directly on the grid game object. Here we have the terrain manager. And in this script we can see how it has references to the various tile maps. And then it's using various functions like the tilemap.setTile in order to modify a certain tile on a certain position. So if you want to learn how to handle gameplay directly inside the tile map, make sure you check out this script. Although personally, I must say, for me, when I want to handle some logic inside of a grid, personally I really just use my own grid system, which is really made to use generics, so it feels much more adaptable. But if you just want to use the built-in into the tile map, then definitely look into this one to figure out what you can do with it. Then yet another set of tools that was used heavily in this sample are the 2D rigging and IK tools. Again, there's another excellent article, super detailed exactly on this topic. This one is really insanely detailed. If you've never played around with the 2D bone tools and sprite swapping, like for me, I haven't, then I highly recommend reading through this entire article. It all starts off obviously by drawing the character properly, by drawing the body parts separately. Now for this you can draw the body in really any image program, but if you use Photoshop then the PSD importer can be extremely useful. Here I have the character PSD file selected in Unity, and if I open the sprite editor, look at that, all of the body parts all neatly separated. However, here is the file open up in Photoshop. Note how all of the body parts, these are all placed correctly, except for the hair, that one for some reason is appearing in front of the face. But everything else on the arms and legs and so on, all of those are placed correctly. And note how they are all on separate layers, all on separate folders. The old way of drawing some sprite sheets would be to draw them manually separated. So you draw one arm here, one leg here, one foot here, one hand here, and so on. Drawing it like that is really tricky to make sure that everything fits correctly, so this is obviously a much better method. And if you use the PSD importer, you can do it exactly like this, place it on separate layers, and then Unity automatically separates all of those layers into separate parts, makes them fit correctly as tightly as possible, and automatically creates individual sprites out of each body part. So just this tool alone is insanely useful. Personally, I remember trying to manually draw sprite sheets quite a long time ago, and it was all such a huge pain to draw them manually. So being able to automate this process, this is super awesome. If you make 2D games, definitely make sure you use the PSD importer. So with this here, we have all of the separate body parts. Now for this game, it's a 2D top-down game, so they opted to go for just 4 directions. As you can see, it's up to you to decide how many directions you want to have. Obviously, the more you have, the more responsive your game looks. But obviously a lot more work to create all of these individual directions as opposed to just these. Over here for the sprites, we can see we've got the head front, the head back, and the head to the side. And for the other side, they simply invert this one. Then note how they also drew various hand poses. These are used in the animation, which I'm going to cover in a bit. Alongside this texture is something that we've already seen, which are the secondary textures. So we can see, and yep, this one also has a normal map and mask texture. This is how we can get those really nice lighting info. And then here in the article, here is the really awesome part, rigging in the sprite editor. This is how you can very easily create bones directly inside of Unity. So over here, again, selecting the PSD character, here is the entire character, and on the top left corner, we can go down into the skinning editor. And up here we can see the skin for our character, for our mesh, along with all the bones and what objects they affect. This bone tool is really super powerful. Using this makes building 2D animations so much easier than using sprite sheet animations. Adding bones is really easy, which means you can set up all kinds of individual bones. You can really go super detailed and make sure to animate just the ears, the eyes, and so on. They also added bones just to the eyelids, the eyebrows, and so on. So using this tool, building something like face animations, that is so much easier. Then after assigning bones, there's a button to automatically add some geometry. You can play around with this, but obviously don't go way too crazy, otherwise you end up with a million polygons. And once the geometry is set up, then you can play around over here with the weights. And you basically just select the bones and then draw directly on the sprite. So for example, double click over here on this bone. So on this shoulder bone, right now it's obviously only affecting the right shoulder, but if I want I can paint the left shoulder, and there you go, now it affects both of them. So it just takes a bit of work in order to go individually by each bone, in order to paint exactly where you want it, and everything behaves perfectly. When you have everything set up correctly, you should be able to play around with most of the bones in order to get any animation, any pose that you want. This character is already really nicely animated, so you can see how very easily I can build all kinds of interesting animations, interesting poses, and everything works great. Then of course, one huge benefit of bone-based animation instead of hand-drawn sprite sheets is you can easily apply the same animation to multiple different characters. In this game, all of the characters share the same animation despite having very different visuals. You can do that using Sprite Swap, which lets you use the same bones or animation but swap the sprites on top of it. All the data is stored in these various sprite library assets. So this one, the character itself, has a sprite library using this asset and we can inspect it. Here, as you can see, this one has both categories and labels. This one is the dummy base character. So they set up this base sprite library asset with the nose from the front, the side, the ears, and so on. They set up all of these. And then they basically just extend them in order to make these various other ones. So for example, here for the head for the farmer, they simply use a different reference to a different sprite. With all of that, here is the character, and in order to swap out the character, really just swap out over here the sprite library asset. So I've swapped it out for the farming sprite library, but for some reason this one doesn't update immediately. But if I play the game, yep, there's my completely different character, and if I want to change it, just swap out the sprite library asset, and yep, there's another character, and there's another character. Again, all of them sharing the same animations, but having some really nice different visuals. And of course, for the animations, these are set up in the regular animator. You create animations by modifying the bone positions. So pretty simple, just like you would normally do. And the animator itself also has an interesting setup. Note how they use different layers for both the head and the base animations. Also note how this little A here, this means that this layer over here, the blending is set to additive, meaning it adds on top of all the other animations. Then the base layer has the various movement and action, so walk, watering, eating, and so on. And finally, for the last layer, flip, this one just has two animations, face right and face left. And if we go into the character and we inspect those animations, we can see that really all they are recording is over there the scale.x. So on face right, that one is on 1, and on face left, that one is on -1. So they really just modify the scale.x in order to look left or right, and then the base layer works on top of the flip layer and the head layer on top of that. Now for building the animations, like we saw, you can just use the regular animator window. Just manually move all the limbs, all the bones, and everything will work correctly. Or you can also use IK, which is inverse kinematics. Basically, this is how you can move just a hand, and then it will automatically move the lower and the upper arm in order to place them in a position where it makes sense for the hand to reach that point. Using IK is always really awesome. I already covered the tool that is used for making it in 3D, and over here, as you can see, that tool also exists in 2D. This one really helps speed up the animation process significantly. The way this works is over here, the prefab character base, this one has an IK manager, and as you can see, this one has all kinds of limb solvers. So let's see this one, the arm right limb solver. And if you ever used any IK tool, then this should be pretty familiar. You really just got the effector, which is what is going to be affected by this. And then you've got the target. So the target is really just an invisible position. And now if I move just this target, look what happens to the rest of the arm. As you can see, everything moves correctly in order to make sure that the hand always places exactly where I'm targeting. So you can see how it saves a ton of time to be able to animate just this one target instead of having to animate every individual bone to make sure it makes sense. And of course, you can also make this dynamic, meaning instead of controlling the effector with a static animation, you could simply control it through code to make it grab a dynamic object or something like that, exactly like I covered in 3D in a previous video. You can do the exact same thing with this 2D tool. But remember that while using bones and IK is indeed super useful, sometimes a simple animation is more than good enough. For example, if we look at the lamp, we can see how the lamp over here has a simple animation just swinging left and right. So for these kind of use cases, you really just need an animation, so not even an animator, just the old school animation component. It is super simple, but of course works great for the super simple use case. Then yet another animation you have are just simply flipbook animations. So for things like splashing water or these kinds of effects, these can be super simple flipbook animations that are simply played by a simple shader. And speaking of shaders, that is obviously something that always gives some excellent polish. And for that, there is yet another super detailed article that is coming soon, all about 2D special effects with the VFX graph and shade graph. Which again, some of you might not even know that VFX graph already works in 2D. When it came out, it was 3D only, but in a previous version, they've already added 2D support. And if this sample and all of these examples is enough, if you want to learn even more about Unity 2D, there's even a bunch more links. You can check out the previous excellent 2D samples. One of them is the Lost Script. This one has tons of interesting particles, lots of interesting stuff. And then you've got the Dragon Crashes demo. This one has tons of bone animation, sprite shapes, and lots of stuff. I also made a video doing an overview on this one. And for more ebooks, there's one all about 2D game art and animation. There's one, an introduction to URP for advanced Unity creators. I also made a nice video overview on this one. You've got a book all about HDRP, just in case you want to push Unity to its visual limits. And you've got another ebook. This one is all about advanced visual effects in Unity. So if you want to dive deeper into the VFX craft, definitely go ahead and read this one. Alright, so that is the latest official Unity 2D sample, showcasing all of these awesome 2D tools to help you make awesome 2D games. If you do want to make 2D games, then I highly encourage you to download this free sample and check out all of these ebooks. Personally, I've been more into 3D recently, so for me it was great to read all of this and get a refresher on all of the 2D tools that Unity has. It's really amazing how much Unity 2D has evolved over the past few years. When I started making games with Unity back in 2012, back then I was making 2D games, but I had to use all kinds of weird 3D tools and making them look like 2D, so it's really amazing that there are so many dedicated 2D tools nowadays. Nowadays, thanks to all of these awesome 2D tools, you can make excellent games like the ones I mentioned in the intro. So, check the link in the description to download the sample for yourself, check out all these articles and read through all of them. Thank you for watching, and I'll see you next time.